Hello everyone, I am Dr. B. Vinodhini, Associate Professor of SNS College of Technology. In this lecture series of design and analysis of algorithms, already we have seen a lot of analysis methods. In today's topics, we are going to see about that what is the backtracking and branch and bound. So in the backtracking, we have a several number of applications. So today's class, we are going to see about what is the Hamiltonian circuit problem. So before going into the Hamiltonian circuit problems, we have came to know about what is a backtracking and branch and bound. So backtracking and branch and bound is algorithmic technique to solve the given problems. So the backtracking is used to solve the decision problems. The branch and bound is used to solve the optimizations problems. So in the backtracking for tracing, we are using the depth first search. In the branch and bound, we are using the breadth first search for tracing that given algorithms. So the backtracking contains the feasibility solutions. Here it contains the bounding functions. That means we are going to find in the branch and bound what is the upper bound and lower bound of the given problems. So backtracking is more efficient compared with the branch and bound. So the application of backtrackings are N-Queen's problems, graph coloring methods, Hamiltonian circuit problem, knapsack problems, and some of the subset problems. The applications of branch and bound is a job sequencing, traveling salesman, and knapsack problems. This is about that introduction about what is a backtracking and branch and bound. So in Hamiltonian circuit is comes under the backtracking. So what is a Hamiltonian circuit means we have to find the Hamiltonian path that should follow the given constraint. So we have to visit all the vertices exactly once in the given graph. The graph should be the undirected graph. So we have to visit all the vertices exactly once. And another constraint is we have to, there is a edge between the last node to the first node. That means where we start means that source itself we are going to enter. That is a Hamiltonian circuit. So it is defined as a cycle that passes to all the vertices of a graph exactly once except the starting and ending vertices, that is the same vertex. This is about the Hamiltonian circuit definition. So this is the graph. This is the undirected graph. So in that graph we are going to find out whether the graph contains the Hamiltonian path or not. So for that we are going to trace about that given problem using the depth first search. So start with the source vertex. So here in this graph A is a source vertex. So start with the source vertex A. So after that we have to find out that what are all the adjacents of A. The adjacents of A's are B, C, D. So in that we go to the next adjacent B. So from that B again you have to find what is the adjacent of B. That adjacent should not be visited before. So the adjacents are C and F. That is the second level. So after that go in depth, go to the C edge and find out the adjacent of C. The adjacent of C is D and E. So in that D and E, first go to the D. So next find the adjacent of D. The adjacent of D is an E. The adjacent of E is a F. So finally we visit all the nodes and it end with a F, but it should not, there is no any part edge between the F and A, so that is called as a dead end. So you have to backtrack the same path. Again go after backtracking, we go to the edge 6, that is an E edge. So again we have to find out what is the adjacent of E from C to E. So adjacent of E's are D and F. So D is also the dead end and F is also the dead end. So again backtrack to the previous levels, that is go to the B. From B there is a two path, that is a C and F. In the C path there is a no edge between the last to the first vertex. So in that we have to try the another vertex, that is a F. So from the F we find the what is the adjacent. The adjacent are two adjacents are B and E. So B is already visited, so go to the E. So from E we have two adjacents C and D. So go to C, after that go to D. From D we have, there is a path. So when you reach D, in that path we visit all the vertices in the given path, that is A, B, F, E, C, D. So all the 6 edges vertices are visited. So finally D to A there is a path. So we have reached the A. So this is the there is a constraint satisfied here. There is a edge between the D to A. So this is the Hamiltonian path we have find in the given graph. From what is the path? The path of the Hamiltonian given graph is the A to B and B to F, then F to E, E to C, C to D and A. So this is the Hamiltonian circuit for a given path. Thank you.